My name is Vikas S. Kumar and I am studying in Sri Venkateshwara College of Engineering and my USN is 1VE22IS 060. The subject is Mathematics for CSE stream. The topic is Difference between one-way and two-way ANOVA. Introduction. ANOVA, analysis of variance, is a statistical method used to analyze the differences among groups means in dataset. A one-way ANOVA and two-way ANOVA are two variations of ANOVA used in different situations. One-way ANOVA. Number 1. Number of factors. One-way ANOVA analyzes the variation in a dataset caused by one categorical independent variable or a factor with three or more levels, means groups. Second one, use cases. It is used when you have a one categorical independent variable and one continuous dependent variable. Example, comparing an average test scores of students across different teaching method A, B, C. Interpretation. One-way ANOVA tests whether there are any statistical significant differences between the means of groups. If a p-value is less than predetermined significance level, example 0.05, then we reject the null hypothesis and conclude that at least one group mean is significantly different from others. Two-way ANOVA. Number of factors. Two-way ANOVA analyzes the variation in data sets caused by two categorical independent variable or factors simultaneously. Use cases. It is used when you have two categorical independent variables and one continuous dependent variable. Example, examining the effect of both teaching methods and student gender on a test score. Interpretation. Two-way ANOVA tests whether there is significant main effects for each independent variable and whether there is a significant interaction effect between two independent variables. Main effects refers to individual effects of each independent variable on the dependent variable. Interaction effects refers to whether the effort of one independent variable depends on the level of other independent variable. Key differences. Number of independent variables. One-way ANOVA analyzes the effect of one independent variable, whereas two-way ANOVA analyzes the effect of two independent variables simultaneously. Complexity. Two-way ANOVA accounts for potential interaction between two independent variables, making it more complex than one-way ANOVA. Interpretation. Two-way ANOVA provides information about main effects and interaction effects, whereas one-way ANOVA provides only information about group differences. Real life uses of ANOVA. Biomedical researches. Drug trials. ANOVA is used to analyze the effectiveness of different drug or treatment by comparing the mean response across the multiple treatment groups. Clinical studies. Researchers may use ANOVA to examine the impact of various factors, example age, gender, genetics, on health outcomes. Second, education. Educational research. ANOVA is utilized to evaluate the effectiveness of a different teaching method, curriculum, interventions, or educational program by comparing the mean performance of students across the multiple groups. Standardizing testing. Standardized testing. ANOVA can be used to assess the fairness of standardized tests by analyzing performance differences across the demographic graph. Market researches. Consumers' preferences. ANOVA helps analyzing consumer preferences by comparing mean rating over responses across the different product variants, pricing strategies, or marketing campaigns. Brand loyalty. Researchers may use ANOVA to assess brand loyalty by comparing customer satisfaction scores across the various brand or product categories. Agriculture. Crop yield studies. ANOVA is employed to analyze the impact of different fertilizers, irrigation methods, or planting techniques only crop yields by comparing mean yields across the different treatment groups. Livestock studies. Researchers may use ANOVA to assess the effective of various factors, example diet, environment on livestock, growth rates, or milk production. Fifth, manufacturing and quality control. Product quality. ANOVA helps in identifying factors influencing product quality by comparing mean measurements, example dimension, strength, across different manufacturing processes or materials. Processes improvement. Anova is used to optimize manufacturing processes by analyzing mean performance matrices across the different processes, parameters, or production lines. Psychology and social science. Behavioral studies. Anova is applied to analyze difference in behavior, attitudes, or response across the various experimental conditions, treatments, or a group. Social survey. Researchers may use ANOVA to examine the impact of socio-economic factors, cultural background, or environmental condition on the social attitude or a behavior. Environmental science. Ecological studies. ANOVA helps analyzing ecological data by comparing mean measurements, example species diversity, habitat characteristics across the different environmental condition or treatment groups. Pollution, population monitoring. Researchers may use ANOVA to assess the impact of pollution sources of environmental parameters by comparing mean pollutant level across the different locations or a time period. In engineering, ANOVA analysis of variance is a valuable statistical tool used in various applications to analyze difference among groups means group means and identify factors that influence outcomes. Here are some common use of ANOVA in engineering. First, product designing and development. Designing of experiment. ANOVA is used to analyze experimental data for DOE and studies to identify significant factors affecting the product performance, quality, or reliability. Product optimization. Engineers use ANOVA to optimize the product design by analyzing the effect of different designs, parameters, or configurations on a key performance matrices. Second one, manufacturing processes. Processes involvement improvement. ANOVA helps optimizing a manufacturing processes by analyzing the effects of a process parameters, example temperature, pressure, speed, on a product quality, yield, or an efficiency. Quality control. Engineers use ANOVA to monitor and improve the product quality by analyzing variations in measurements, example dimension, hardness, across different production runs or manufacturing lines. Third, reliability and failure analysis. Reliability testing. ANOVA is employed to analyze reliability test data and identify factors influencing product reliability or failure rates. Root cause of analysis. Engineering Engineers use ANOVA to investigate the root cause of failures or defects by analyzing variations in failure modes across different operating conditions or environments. Fourth, structural and material analysis. Material properties. ANOVA help analyze the effects of material composition, processing methods, or treatment conditions on material properties. Example strength, stiffness, fidget, life. Structural testing. Engineers use ANOVA to analyze structural test data and evaluate the effects of design parameters or loading condition on structural performance. Fifth, environmental engineering. Pollution control. ANOVA is used to analyze environmental monitoring data and assess the effects of pollution sources or mitigation measures on the environmental parameters. Example, air quality, water quality. Climate change studies. Engineers use ANOVA to analyze climate data and assess the impact of a climate change on its infrastructure, ecosystem, or natural resources. Sixth, energy system and efficiency. Energy efficiency studies. ANOVA helps analyzing energy consumption data and identify factors influencing energy efficiency or performances in system. Example, HACV systems, renewable energy systems. Optimization of energy system. Engineers use ANOVA to optimize energy system by analyzing the effects of design parameters or operational condition on energy consumption, cost, or emission. 7. Process control and optimization. Control system ANOVA. Control systems. ANOVA is employed to analyze process control data and assess the performances of control system by comparing mean responses across different control strategies or tuning parameters. Optimization algorithms. Engineers use ANOVA to evaluate and optimize optimization algorithms by analyzing variation in performances matrices across the different algorithm configurations or parameter settings. In this example, there are three processes A, B, C are tested to see whether their outputs are equivalent to the following observation or of outputs are made. A 10, 12, 13, 11, 10, 14, 15, 13. B 9, 11, 10, 12, 13. C 11, 10, 15, 14, 12, 13. Carry out the analysis of variance and to conclude varieties. Varieties A 10, 12, 13, 14, 15, 13. B 9, 11, 10, 12, 13. C 11, 10, 15, 14, 12, 13. You have to add all the sums. And the sums are 98, 55, 75. And you have to sum up the total. The total becomes 228. The squares of 98 is 9604. The square of 55 is 3025. The square of 75 is 5625. The CF is equals to t square by n is equals to 220 square by 19 is equals to 2736. TSS is equals to summation I summation g of xi xj square minus CF. Varieties are A, B, C. You have to square those values of A, B, C and add, then the sum will be 2794. TSS is equals to 2794 minus 2736 is equals to 58. SST summation I ti square minus ni minus CF. You have to separately take the squares of A, B, C and divided by the number of terms in the A, B, C column is minus the CF. The CF is 2736 and the sum total will be 7. SSC is equals to TSS minus SST and TSS is 58, SST is 7 and the total is 51. The source of variation, you have to draw a cover for table. Source of variation, between traits, error, totals. Degree of freedom, SSC, SS, MSC and F ratio. Between traits is equal to K minus 1, that is 2. There are 3 tables A, B, C. So K value will be 3 and 3 minus 1 is 2. N minus K is, N means the total number of elements in the tables. N is 19, minus 3 is 16. N minus 1 is 19 minus 1 is equals to 80. SS is equal to SST. The following value of SST is 7 and SSC is 51. MST is equals to 3.5 and MSC is equals to 51 divided by 16 and that would be 3.18 and F ratio is equals to 3.5 divided by 3.16 and the ratio will be 1.07. 1.07 is less than 3.63, hence accepted of 0.5 degree freedom of significance level. Since evaluated value is less than 3.63 for the f is equals to 2,16 at the 5 degree level of significance, hence the null hypothesis is accepted. Thank you.